Hey gang, welcome back. So like I said in the previous video, what I'm going to do now is I'm going to kind of go over the notes today to explain this new transformation of a reflection. Again, I don't have the printed out version or the completed version in there, but I do have the blank version in your file folder there. So you could print it out, fill them in, or you could just simply follow along. Choice is up to you. So again, we're in the unit of transformations. Sort of started off with a little introduction to, or a review of the coordinate plane, the quadrants, the axes, and a few simple lines. Then over the last several days, we've been looking at the transformation called a translation. And again, generally speaking, this is a slide on the coordinate plane. So you're just taking an image and moving it up, down, left, right. So then we could describe that in several different ways. We could do it using a coordinate. And again, those look like this. If you had x plus 2, sorry about the handwriting, and then y minus 3. Again, that's the coordinate description right there. The vector of that, again, basically you just take the numbers out and use these weird brackets like this and like this. So this would be the same translation but written in coordinate form, and then you could do it in words where you would just go like this goes to the right 2 and it goes down 3. Oops, down 3. So again, that's what we spent the last couple of days on. So today we're going to look at a new one called a reflection. As I mentioned in my little video, a reflection, in order for it to happen, it needs a line of reflection. So the one I used in the kitchen there was the mirror. The mirror was my line of reflection. So down here you can see I have a line of reflection right here. I can tell that because this is my pre-image point here. I don't see an apostrophe on it, so it's not a prime, so that is your pre-image. And this is your reflected point over here. So as I pointed out in the video, again, the distance from Joey to the mirror was the same as the distance from the mirror to his reflection. And we're going to use that to come up with the graphs of these points, and I'll show you how. The only real anomaly that happens here is when the pre-image and image are the same point. That means that the point is on the line of reflection. That doesn't happen that often. But another thing to remember here is that a reflection is also an isometry. I mentioned that during the translation. And just keep that in mind that isometries are when the pre-image and the image are congruent to each other. So isometry. And that is congruent. Pre-image and image are congruent. So here's another description of what a reflection is, so on and so forth. So here you still have a line of reflection, which you need in order for a reflection to take place. Then it has pre-image points BUG. And you'll notice that they spell bug in a clockwise direction. Over here on the reflection, you get that reverse orientation. So now you need to go to a counterclockwise direction to get it to spell the word bug. So again, that kind of illustrated that with Joey's t-shirt and him raising his right arm. All right, so let's do an actual reflection. So we're going to look at two reflections today, and that's one over the x-axis and one over the y-axis here. So looking at these, what I want to look at is, we'll use purple. So I want to reflect this first one over the x-axis. So this is my line or my mirror right here. And again, what I want to do is I want to go to that line and then do the same distance on the other side of that line. So what I mean by that is n is my pre-image point. If I want to find n prime, I'm going to go to the line of reflection. Notice I went 1 unit, and I want to do 1 unit in the other direction. So that's going to be my n prime right there. So if I do the same thing with s, to go to the line is 2 units, 2 units on the other side. I end up with that as my s prime. Then y prime would end up over here, and z prime would end up over here. So now you can see the reflected image in its reverse orientation from the pre-image. All right, one thing I want to point out here is, well, let's reflect over the y-axis next. So now instead of using this horizontal axis, I'm going to use the vertical one here and reflect it over that, but same thing. I'm going to go to the same distance on both sides of the line. So starting with n prime, again, I go 2 units, and I'm going to go 2 units on the other side, so there's my n prime. Do the same thing with y here. I go 1, 2, 3, 4, 1, 2, 3, 4, so there's my y prime, and then 2 on the other side. You'll know if you messed up because it won't be an isometry anymore. They won't be congruent figures, and you'll be able to tell. So you can tell it's reflected over the y-axis. All right, one thing I want you to notice is what happens here to the ordered pair. So notice that n here is at 3, -1. So n is at 3, -1. Notice where n prime goes up when I reflect over the x-axis. Here's n prime right here. It's at 3, +1. So n prime's at 3, 1. So the z prime, or let's do s prime. S prime, so let's see. S is at 1, -2. S is at 1, -2. That's the pre-image point. So we'll look at its image point, which ends up here. Notice it's still at 1, but now it's at +2. So at this point, I think you can see what's going on. It's almost the same ordered pair. The only difference is the y value has changed sign. So let's take a look at y. Y, the pre-image point, is at 2, -5. Notice its image point, again, it's still at 2 on the x-axis, but you went in this direction, so it's at 2 positive side. So again, that y value is the only thing that changed sign. So it moved from -5 to +5. So z will follow suit as well. Let's see what happens when I reflect it over the y-axis here. So you'll notice, let's find a pre-image point. We'll use n since I started with that one before. Notice that's at 2, 2. So n is at 2, 2. N prime, where does that end up? So it's at -2 now on the other side of the y-axis, but it's still at +2. So this is at 2, or -2, 2. All right, let's see if we can do another point and look for a pattern then. So we'll do y. Y is sitting at what? 1, 2, 3, 4. 1, 2, 3. So 4, 3 for y. So 4, 3 for y, and that's y prime ends up at what? -1, 2, 3, 4. So -4, +3. So you can see the pattern hopefully by now. Oh, this should be what? N prime here. I switched these by accident. So this should be y prime. But I just wanted you to see the pattern. So that's at -4, +3. So now instead of the y value changing sign, you can see that the x values is changing sign here. So that's what I wanted to point out here. See, the y values stay the same, but it's the x values that change sign, which kind of summarized down here. So the coordinate rules for reflections. So again, if I reflect over the x-axis, that means you're going to change the sign on the y value. If you reflect over the y-axis, that means you're going to change the x, or the opposite of the x value. So again, down here to illustrate that, if I have point P at 2, -1, so 2, -1 is right here, there's my P, and I reflect it over the x-axis, that means P prime is going to end up here. But if I just use the coordinate point, again, P prime, again, the x value stays the same, and you just change the sign on the y value. So you can see that P prime ends up here. Same thing down here. If I take P and reflect it over the y-axis, then again the pre-image points at 2, -1 right here. Now I'm going to reflect it over the y-axis. So P prime now. Remember, you changed the sign on the x value and keep the y value the same. So you can see it here, -2. Or 2, -1, or -2, -1, sorry. This P prime ends up over there. So it's kind of an illustration of those two rules. So over here, the practice problems, it wants you to graph the pre-image, which would be these ordered pairs right here in this one, and then it wants to be reflected over the x-axis in the other one. So let's see if I can do that. So let's see, -2, -1's right there. So there's D. E is at -1, +3, which is right there. Then F is at 3, 2, 3, -1. So there's my triangle. So now I'm going to come up with the ordered pairs, and I'm not going to use the graph. I'm just going to use the rule. So again, if I reflect it over the x-axis, that's this one. Remember, the y values are going to change. So this stays the same, -2. And what changes is the sign of the y value. So this would become +1. So again, E would be -1, -3. And then finally I have 3, +1. So then if I graph that, -2, 1 is going to be right here. -1, -1, 2, 3 is right here. And then finally 1, 2, 3, +1 is right there. So that is the reflection over the x-axis. Kind of weird with the x-axis going right through the middle of the shape. That's the way it ends up. So down here, so now I have a quadrilateral, but I'm going to flip it over the y-axis. So again, the pre-image is at, we'll do it in a different color, 1, 4. So 1, 1, 2, 3, 4 is right there. 3, 2, 1, 2, 3, 2 is right here. 2, -2 is right here. -3, +1 is right there. So now I'm going to flip it over the y-axis. I'll use the rule instead of the graph on this one. So now if I'm flipping it over the y-axis, remember the x value changes, y value stays the same. So the x value is going to be opposite. So -1, keep the y value the same. B, again, opposite in x value would be -3. Keep the y value the same. Then change the x value. Keep the y value the same. And then change the x value. Keep the y value the same. So let's see what that looks like. -1, +1, 2, 3, 4. I kind of missed the spot there. -3, 1, 2, 3, down 1, 2. And then -2, or -2. So -2, -2. Oh, so -2, -2. Something's wrong. So hold on. So this one was -3, 2. Oh, shoot. -3, 2 is this direction. 1, 2, 3, 1, 2. Sorry about that. Let's erase that other dot. And then, so where am I at? So -2, 2. -2, -2. Right there. And then 3, 1. 1, 2, 3, 1. So there's reflected over the y-axis. So next on here, oh, describe the transformation. Don't worry about this one. We'll get to that one. But this one's a reflection. So this is a reflection over the x-axis. I can tell that. This one looks to be a reflection over the y-axis. So again, reflection over the y-axis. And then this one's a reflection over the x-axis again. Reflection. So you'll have questions like that.